Today, we return to one of the most geologically active regions on Earth to look at one more mineral we almost missed. Forsterite. Forsterite, named in 1824 in honor of Adolarius Jacob Forster, a German mineral collector and dealer, is an orthorhombic mineral with a hardness of 7 on the Mohs scale and a composition of magnesium, silicon, and oxygen. It usually only forms under extremely high temperatures and commonly shows a conchoidal fracture. Its melting and crystallization points at Earth's surface are approximately 1890 degrees Celsius. Due to this property, Forsterite is among the first mineral to crystallize from magma. As magma cools, minerals crystallize under different temperatures and chemical conditions. Forsterite typically forms in the upper mantle in mafic to ultramafic magmas, where temperatures and magnesium-rich conditions are optimal. Its crystallization alters the magma's composition, a process called Bowen's reaction series. The series states that under cooling conditions and over time, Forsterite forms early, reacts to changing conditions, transforms, and rarely survives the journey to the surface. This is why Forsterite-rich olivine is the most common mineral in the mantle, but is comparatively scarcer in the Earth's crust. Occasionally, Forsterite crystals endure these changes in conditions and are eventually released at the surface. This beach is green because it is filled with olivine crystals dominated by Forsterite. You are looking inside an ancient volcanic tuff cone formed from explosive eruptions. Here, Forsterite survived because the Bowen reaction series broke down just in time, being carried in rapid volcanic eruptions and subsequent cooling. Over millennia, as each wave slowly rolled on one side of the cone while eating away the softer basaltic rocks. And as the cone sank into the ocean, all that was left was the tougher, harder, and denser mineral contained inside. Many magmatic systems, poor in silica, produce these crystals along a compositional spectrum called olivine. Without analysis, it is difficult to determine where a crystal falls on the spectrum, which is why the name olivine is needed. Both belong to the olivine group, with each ideal composition termed an end member. The magnesium-rich end member is Forsterite, while the iron-rich end member is named Phyalite. In general, magnesium-rich olivine tends to be lighter and more transparent, whereas iron-rich composition tend to be darker and more opaque. The iron-magnesium ratio, oxidation state, and associated minerals influence olivine's color range. Forsterite can be green, yellow, clear, red, or orange. Most olivine crystals are intermediate, but to be classified as Forsterite, the mineral must contain less than 10% iron substituting for magnesium. The Bowen reaction series only tells part of the story for this mineral. Forsterite can also form in metamorphic settings through solid-state chemical reactions, rather than from melted rocks. In the presence of dolomitic marbles with quartz or serpentinite, pressure and temperature allow Forsterite to thrive as these minerals break down. Expanding this context beyond geology, when olivine is of sufficient quality to be cut into a gemstone, it is known as Peridot. The term Peridot is therefore used primarily in the jewelry industry. Ancient Egyptians referred to it as the gem of the sun, believing it would protect its wearer from the terrors of the night. In fact, they were not too far off the mark. Forsterite's scientific value extends outside Earth. Recently, it was identified in interstellar dust exposed to intense cosmic radiation through the use of spectral analysis. Just what puzzles of planetary formation hide in that interstellar dust? Does this mean the process that helped Earth's formation are ubiquitous in the universe? Whether your head is buried in the sand or up in the clouds, this green mineral is certain to leave an impression on your imagination. From the deepest trenches to the highest volcanoes, Forsterite signals the extreme prevailing conditions in Earth's mantle and around other stars. It was also among the earliest minerals to shape and cover our planet. Next, we'll explore what happens when Forsterite makes its way inside the mountain core. Stay tuned to our channel to learn more about this mineral's incredible journey. For more on everything about minerals, visit my channel, Mindex. Thank you for sticking to the end, and please do not forget to click the like and subscribe buttons. Peace out. Or approximately, the FEMG. What